This happened the other day, a student that was watching, he should have been watching, emailed me, I have 3 questions, these 3 problems, and those were the 3 that we did in class. Yeah.
For 20C, I just want a confirmation, so if something that is a fraction of the whole gets increased by 1%, so something that is a percent of a whole gets increased by 1%, how much does the whole thing increase by?
This one's the cost of the oil problem?
Yeah. So it says,
Yeah.
if refinery, which is 10%, cost increases by 50%, what percent should the total cost increase? I said by 0.05%, because you take 10% and you multiply it.
Yeah.
No, I think one of the things I did was I actually did it like a weight. I did like a weighted grade where I had all of them as like weights, and then multiplying by 1, except for the refinery, which I multiplied by 1.5.
Yeah.
And then however much greater it was from one or 100%, that was the total increase of the cost.
Yeah, that makes sense. Yeah, you just weight it. Mm-hmm. Instead of it having a weight of 10% times 1, it's going to be 10% by 1.5, which.
And wouldn't I just be able to multiply those decimals?
Yeah.
Turn the percents into decimals and then multiply them?
Yes, you can. Another way to look at it is if this whole thing is $1, gasoline is $1, 10 cents comes from a refinery or refining costs. And then if you increased refining costs by 50%, your 10 cents, you have to have another half of that 10 cents come back. So then it's 15 cents. So then your entire cost of the gasoline goes up from $1 to $1.05. So the cost went up by 5%, which is half of that 10%. If crude oil prices doubled, then your dollar would cost $1.73, because you'd have that 73 2 times if you doubled.
Wouldn't it be 36.5?
If it doubled, it'd be twice the 73.
Oh, I see, yep.
Yeah, it'd be twice the 73.
And then okay. So then my second question was on 24.
Okay.
And it's just, there are 2 terms, one with a variable and one without, and I was wondering how to simplify them. 24C.
C.
Mm-hmm.
Yeah. Same question that was brought up yesterday.
I got it to 9z plus 6. I just divided everything by 3.
Oh, these don't show up real pretty. Okay.
And so I wasn't sure if I could just go vertically, just like straight horizontal, meaning that I could simplify it to 8z plus 4, or 8z plus 3.
Why would you get 8? Because 3 times 8 is 27?
Because
not.
sorry, when I simplified them to 9z plus 6 over z plus 2.
9z plus 6 over z plus 2.
I divided everything by 3.
So you simplified by dividing everything by 3. Okay, so let's see. So you pulled a 3 out of the top, right? You can't just put it out in front. So then you'd have 9z plus 6 over 3 times z plus 2, right? Okay, so that cancels. Can you go further?
That was what my question was.
Yeah.
I was wondering if I could just simplify it the way it was, and so.
Like this over this and this over this?
Yeah, this over that.
Only if this was something like this.
Yeah, that's what I thought.
But
because
because
then I'd still be left with 6 over z, or 3 over z and 9.
No, this would be like 9 plus 3, which would be 12. But that's not what that is. Because you have to add the 6 to this, you have to add the 2 to that Z
Right.
before you do your division. So by order of operations, you can't just say, well, I'm not gonna do that first, I'm just gonna simplify.
Mhm.
You can only simplify when the order of operations is allowing you to. And right here, that's as good as it gets.
Okay.
You can write it without the parentheses. That's as simplified as it becomes. And that's what they wanted us to make sure we recognize, that when we have 2 terms in the numerator and 2 in the denominator, or some situation like this, when terms are separated in numerators and denominators, you can't just pick and choose what you want to simplify. It's done. Unless you can factor something out and then simplify, like what we did with the 3.
Mhm.
But that's it. It's the only way you can do it. Okay? Is that all you have?
Mhm.
All right. So if I put this here, are you going to see okay?
Mhm.
So if somebody's watching us, they're going to see too. They are and they aren't. This is weird. Some days it's like this thing is just fine to be looking at. I'm going to break something. I wonder, what is it that holds? Oh, this one holds this. Yeah, some days I can look at the smartboard and it's just fine, and other days it's not so fine. Okay, so let us go to histograms, creating and using histograms. And I just kind of want to walk through a little bit of what they talk about here, answer some questions, because it's sort of reviewy, and then do you have your computer with you?
Not near my locker.
Okay, put your lockers right there. So what we can do then, we'll get to a point here where we can take some data and just make sure that you can create a histogram using sheets. And then manipulate the histogram.
Google Sheets?
Yeah.
Oh.
Sheets? Yeah, put it into sheets. That's like Excel. Yes. So, let's see here. Distribution, how things are spread out. A distribution is going to be a set of data that you're looking at. We know what histograms are. Histograms are going to have ranges. So when we look at histograms, for example, this histogram here, what they did is they take the number of representatives that each state has in the United States Congress. And how many do we have? We have 2 senators, but how many in the House from Alaska? 1. How many does North Dakota have? 1. How many does California have? A lot, yeah. At the time of this here, they had 53. My guess is they might still have 53. This was in 2007 and 9. I'm not positive, but it's 53. And then the next biggest state is, I think, New York. But looking at the data like this, you have to manipulate it to be able to draw some conclusions. So what they did is they took that data and they put it into 2 different histograms. This is a frequency histogram right here, where it's the frequency, how many times a state shows up having between 0 and, but not 5. Because 5 starts this next, what we call a bin. So this actually goes from 0 to 4. So there are 20 states that have between 0 and 4 representatives. And then there are, what's this number here? 7?
16?
How much?
Yeah, it looks like
Maybe 7?
17.
Let's say it's 17. So 17 would have 5, 6, 7, 8, or 9. And then the next bin here, it looks like there's probably, what, 5? Because 6 would be halfway.
Mm-hmm.
So here's 5, have between 10 and 14, and so on and so forth. And then here's just one state that has between 50 and 53. And there's one state that has between 50 and 54. One state has between 30 and 34. So when they write out these bins and they label them, they have the starting number labeled. And the same thing happens over here. So this is the number of representatives, but rather than have a frequency of how many states, they turned it into a percent. So if you have 20 states, 20 out of 50 is 40%, 0.4. So all of these here are going to add up to 100%, but in a frequency here, this is all going to add up to the number of representatives that there are in the House, which I don't even know what it is. Do you know? I don't know if they said it. How many are in the House of Representatives? That's a question for the other side of the hall. So, let's answer these couple of questions. How many states have between 15 and 19?
Four.
Looks like 4 right here, sure. What percent have 20 or more? So now we got to look from 20 or more.
It looks like 0.08.
Yeah, it looks like these add up. This is probably 0.04, 0.02, 0.02. So 4%, 2%, 2%, so adds up. This is 8% cumulative. Everything greater than. Okay, where's the median? I mean, how would you want to find the median anyway? Which bin would the median lie in?
I feel like it would lie in the 5 to 10 range.
It would. And there's two ways of looking at that, aren't there? How many states do we have? 50. So, to get to the median, how many states do you have to count through when you look at how many reps they have?
24.
And then the 25th and the 26th become the numbers that you use for your median.
So then what do you do with that? Do you go in between them, or?
Yeah, so you count up, so if we took all of these values here and we put them in order, there are 50 values. We would count up from the bottom 25, and we could also count down from the top 25. And we would end up with 2 states. And you find the average between those 2 states. That's how you would do a median. So if we have an odd number of terms, you know, something like this here. If you have an odd number of terms, here they are, that's the middle term. But then as soon as I better do this a little different. As soon as we take an even number of terms, we cross them off, and then we would take the mean of those two, which would be 8. That's how you find a median. You find the average of the middle 2 terms, if you have an even number of terms. But this is 50 terms. So we take 25 and 25, and we find those 2 numbers, and we find the average between them. But all they really want to know is, what bin does that fall in? So here's 20 states, so if we count back down to 25, that's going to fall in this bin here, clearly. And it's such a big bin, falls between 5 and 9. We can also do it with percentages. Here's 40%, and we need to just come up with 10% more, and that's going to throw us into this bin. Okay? Shoot. Got mouse dysfunction today. We've got things falling up on my face. I think this one needs to be changed a little bit. I'm going to move the buttons forward, and then it pulls it up better. These things need to be made shorter, too. All right. Okay, let's go ahead. Go grab a computer. And then, I think in Google Classroom I shared a doc.
Okay.
Here it is. Here's the doc. So that should be a blank. Oh, I left it with work from yesterday. Shoot. This ended up being weird. Shit, Isaac turned his in. You know what I, what I did give to you? when I got mixed up sharing this yesterday, and when I shared it with you, I shared the document completed. Sorry. So what I would do, go in anyway and just open it up. Open up what I shared with you.
Okay.
But then let's delete the histogram and have you build one real quick.
There's no histogram.
There's no histogram on it?
Mhm.
Well, why the heck did I open mine and the histogram showed up?
Maybe because you created histogram.
Maybe because I created it and then I deleted it, now it's not there anymore. It's entirely possible. Okay, so pop it open. And what I have here for you. Yeah. Oh, it's not there. Good. This is a nice thing. Okay, what I have here for you is all these March temperatures that come from this particular activity. These are the daily highs in Lincoln, Nebraska. Lincoln is the capital of Nebraska. So it's on the Missouri River, I think. Is that right? Or is that Omaha? Maybe that's Omaha. So anyway, here all these temperatures are. And what we want to do is we want to take them and put them into a histogram. So I gave you a spreadsheet that contains all of them. So all you have to do is take that data and insert. Yeah, you know better than I. Insert a chart, which is going to then become a histogram. So you should be able to just go and choose. Are you finding it? Mm-hmm. Sweet. Then, what are called bins in the textbook, the size of these bars, so to speak, these are called buckets, I think, in this program. Bins and buckets are analogous. So have you done this before? Have you ever made a histogram? You have? Have you changed the bucket size before? Okay. So if you go to Customize, and then you go to Histogram, here's the bucket size. And there's an automatic setting where you can have numbers, but you can type in anything you want here. You can override it. These are just suggested values. So in the activity, the first thing they want us to do is create a bucket with size 5. So are you there? Mm-hmm. So what I'm going to do with mine is I'm going to make it nice and little like this, and I'm going to put it here because they would like us to compare this to buckets of size 10 and buckets of size 2. So then if I take this histogram and I Command C, move over here, Command V, and then just go to the upper right with the dots. Ooh, yes, edit chart. And then we get right back to that customized place where we can change the histogram bucket size. Mm-hmm. Are you cruising along with that? Or am I going too fast?
I had to unclick something.
Okay. So you just highlight that and make your buckets 2. And then we need to do one where it's 10. Are you all done? Mm-hmm. You have all 3 of them? Mm-hmm. Rocket scientist.
I noticed that you copy and pasted the second one. But you already had the first one in your clipboard. So that was
Oh, I guess I could have pasted again and again and again. Yeah, just old. Golly. So, yeah, I can't say this now, I'm gonna tell you, remind me, I'm gonna tell you something funny about masks.
Okay.
Okay, so if you look at the bucket size of 5 and 2, they're somewhat similar, aren't they? But there are some dead spots in the 2 that don't show up in the 5, so you've got a little bit more detail about where the numbers fall. Yet on the other hand, if you take a look at the 10, now we made the bucket so darn big that we've lost some of the detail.
Yeah, it's interesting how in 2 we can see kind of a definite peak for in the 40s, but with the 10 we see a peak in the 50s.
Yeah, it looks like it has a different distribution, doesn't it?
In fact, even in the 5, we still see the peak in the 40s.
Yeah. And then another one down here. So it's like there's 2 highs. Whereas here it just, kind of more or less flattens out. Yeah. So looking at the shape of histograms is part of what this lesson is about, and using some of the vocabulary. So if we look at these 2 histograms here, these are for temperature. I'm not sure exactly what they are, but they're just like, it's been created for us to look at. So you have a frequency of how often a particular temperature shows up. I guess, this must be the one that we're looking at with the bucket size of 10. So that's back here, isn't it? That's possibly this. Although, you know what happened here? Why ours is a little different than in the book? Notice where they go. They go from 20 to 30. We're going from 25 to 34. So if we changed that, can we? Can we change?
Well, where would we want to?
No. I think in some instances you might want to have your display starting at certain values that are more commonly thought of as starting and ending points. You know, the temperatures in the 20s, in the 30s, in the 40s, that they might be going in that direction. I'm not sure. Can we force this? I thought we could. Try what?
Okay, go horizontal axis. Do the minimum value is 20.
Where, I missed it.
So you go to customize and you go to horizontal.
Here's horizontal, yeah. And then the minimum value is 20. And we don't have to worry about a maximum, do we?
Well, the book.
Let's see, but there it changed it.
Okay.
You don't have to worry about the max, it'll just end it where you want it. So this looks like the book, doesn't it? It goes up to 80 or 79 and then it shows 80. So you could add the 80 on there, I guess, if you needed to. So now this, there's that little dip in the middle and then a peak in the top of that. We still don't have it. Something happened. I am not sure. I'm not going to take time to analyze that. The point behind comparing these 2 is to bring in some of the information or some of the descriptors for histograms. And one of the words that we use is skew or skewed. And if we look at, for example, this particular graph, there's a lot of data that shows up out here in the 50, 60, 70 range. And it's kind of like evenly distributed. And then there's just a few down here. So it's kind of like it's either really big, a higher frequency, or it's a really low frequency of cold. So it seems like what's happening here is that this graph is showing that the data is skewed to the right, or skewed towards higher temperatures. If we look at the table here, this is also skewed, but it tails off. You see how it kind of drops down? You could draw a line, and it almost looks like it would curve. And then it has some small numbers that hang way out here on the edge. So that, oops, sorry. That's like having a tail. This doesn't really have a tail, so to speak. If this was more symmetrical coming down, like if this 50 to 59 was maybe half of as many frequencies, and it'll drop off like that. Well, then we might say there's a tail to the left or a tail to the cooler temperatures. This does not have symmetry, does it? You can't really draw vertical lines left and right. This does not have symmetry. This here, though, the number of customers that's shown, that's very symmetric. And it doesn't really tail off. It just has a very symmetric increasing frequency and then decreasing frequency. So some of the problems here are going to ask you to use descriptors. Here's an interesting couple of pieces of data. This is 1980, and then a projection for 2020 that was done. See if I can make them a little smaller. There we go. We've got it all. So if you take a look at the top in 1980, you see how there's a greater frequency for some of the ages?
Wow.
From when to when? What are the ages that are most prevalent in the population?
In 80?
Yeah.
It looks like, I definitely say 15 to at least 40.
So from here up to 40. So,
Yeah, up to the 35 to 39 bracket.
so these in here. So teenagers and young adults in 1980. Where did they come from?
Boomers.
Yeah, those are baby boomers. So then what's happened here? The baby boomers have gotten older.
And we're finding more ways to keep them alive.
There's more ways to keep them alive. And lots of children. Baby boomers started having kids, not here. They started having kids once they got 5, 10 years older. So in 1980, for example, I was right here in this aqua. And then once we got into this purple, that's when we started having kids. But I remember when we were raising our kids and going to soccer meets and stuff like that, all of these parents that were like 10 years older than us. So if we were 20 here, they were 30 there. So they were still baby boomers. They were early baby boomers. We were late baby boomers. But what happened is this group here, once they got to be older, started having kids. So all of these kids here, this high number of kids, are in part due to baby boomers having kids later. More baby boomers went to college. Went to college, and then it's just like, well, geez, I got all this training now. I'd like to establish myself professionally, so I'm going to wait to have kids. So they would work for 10 years, then figure out that they wanted to have a family. So all of a sudden they're in their mid-30s or 40, and then they decide, oh, it's time for kids. So we saw a lot of things happening there that caused this. Who lives longer? Who seems to live longer? Males or females?
Women.
Yeah. Look it up here in their 80s, even in their 70s, there are quite a few more women.
Still pretty even. I mean, still pretty.
Yeah. Kind of gets even up until around here, about when people retire. Yeah. So, best to jump on this work and do it. So we have this right here.